So, how do you teach an AI how to think? And I'm not just talking about crunching numbers. I mean, how do you get one AI to absorb the actual wisdom of another, more powerful AI? Especially when their brains, their internal code, are completely different. Well, that's the puzzle we're going to unpack today.
Think about it like this. We all know an AI can wipe the floor with a grandmaster at chess. But here's the real question. Can you take its strategic genius, its way of thinking, and transfer that to a brand new AI? Not just teaching it the winning moves, but the reasoning behind them. That's the heart of the problem.
To really get a handle on this, let's picture an AI classroom. On one side, you have your teacher AI. This one's the veteran. It's experienced, powerful, and has totally mastered its subject. And on the other side, you have the student AI. It's the new kid, built with a completely different architecture, and it needs to get up to speed fast. And this brings us right to the main hurdle of knowledge transfer. See, when the teacher and the student are built differently, their internal wiring is just incompatible. It's kind of like trying to run a Mac program on a Windows PC by just dragging the file over. It's just not going to work, right? The whole system is different. You can't just copy-paste the teacher's brain, its internal settings, or what we call its weights, and drop them into the student. So yeah, that easy way out, it's a no-go. We've got to find a much, much smarter way to teach. Okay, so if you can't just copy-paste, what have people been doing? Well, the traditional method is something called knowledge distillation. But honestly, it's a lot easier to just think of it as copying the answers. It's a start, for sure, but as you'll see, it's pretty limited. The most popular technique here is called activation matching. Basically, you show both AIs the same thing, let's say a picture of a cat, and you just train the student to spit out the exact same answer as the teacher. It's like giving a student the answer key to a test without ever actually teaching them the material. They know what the right answer is, but they have no clue how they got there. And the process is, well, pretty straightforward. You give both AIs the same input, you look at their final answers, and you just keep tweaking the student until its answer matches the teacher's. Do this thousands of times, and sure, the student gets really good at parroting the right answer, but it never ever learns the why behind it.
Okay, so that's the old way. And this is where things get really cool. Researchers had this big aha moment. They thought, what if instead of just teaching the what, the answers, you could teach the how? What if you could actually teach the student to think like the teacher? And that is the breakthrough idea behind Jacobian matching.
All right, hang with me here, because this is the key. The magic ingredient is a math concept called the Jacobian. And don't worry, you don't need to be a math whiz for this. Just think of the Jacobian as a map of the AI's sensitivity. It tells you how the AI's answer would change if you made tiny little tweaks to what it's seeing. In short, it's the AI's slope of reasoning. So here's the big picture. The old method, that's just about making sure 2 points on a graph line line up. That's it, the final answer. But with Jacobian matching, we're not just matching the points, we're matching the slopes. We're forcing the student's reasoning to follow the exact same curve as the teacher's. This means it doesn't just learn the answer for one specific input, but for all the similar ones around it too.
And the researchers themselves put it perfectly. They said that matching the Jacobians is the natural result of trying to match the AI's behavior not just at one point, but at all the infinitely many data points nearby. In other words, you're not just learning one isolated fact. You're learning the whole concept. It's way, way deeper. Okay, but here's where it gets, well, just plain elegant. It turns out there's this incredible, surprising link between this abstract idea of reasoning and something super practical. Just adding a little bit of randomness, a little bit of noise to the data.
I know, right? At first glance, these two things seem like they're from different planets. On one hand, you've got this complex mathematical idea of matching an AI's reasoning, and on the other, you've got this simple training trick of just making the data a little fuzzy to make the AI tougher. What could they possibly have in common? Well, get this. The paper proved they are the exact same thing, mathematically speaking. That's right. Forcing a student to get the right answer even when the input is a little noisy has the exact same effect as forcing it to copy the teacher's deep reasoning. It's a beautiful, elegant discovery. All right, so the theory is beautiful, but does it actually work in practice? Let's check out the results from the student AI's graduation exam. So first up, the baseline. We take a student AI, give it very little data to learn from, and let it go. Its accuracy? Just under 45%. Yeah, not great. Pretty much a failing grade. But now, take that exact same student with the exact same limited data
But this time, let it learn from a teacher using this new method. Boom, the accuracy jumps all the way up to over 52%. It's not about more data, it's about better teaching. By learning the how, not just the what, it got so much smarter.
But what about a stress test? What happens when things get messy and the input data is super noisy? Well, the standard model just falls to pieces. Its accuracy plummets. But our new student, the one that learned how to think, it stays strong. It holds its ground, maintaining almost 45% accuracy. It's not easily fooled because its understanding is just so much deeper. And we see the same story here. When you train a student from scratch, you get a decent score. The old copy the answers method gives it a nice boost. But when you add Jacobian matching on top, you get an even better score, closing the gap with that oracle, which is like the theoretical perfect score. It just works. Okay, so we've looked at the theory, we've seen the results, it clearly works. But let's zoom out. What's the big picture here? Why does teaching an AI how to think actually matter?
Well, it really boils down to 3 huge benefits. First, faster training. You can get amazing results with way less data. Second, more efficient AI. You can take the brains of a giant, expensive model and distill that wisdom into something small enough to run on your phone. And third, more robust AI. We're talking about creating models that can handle the messy, unpredictable real world without breaking.
What this research really does is open the door to a future where AI models don't just learn on their own, but can actually teach and mentor one another, passing down not just information, but real wisdom. And that leaves us with one final big question to chew on. If AIs can truly teach each other how to think, what's the very first problem we should ask them to solve together?